Everyone. This is our third official webinar. I know we've kind of been we've been in a lot of webinars, but it's our third official one. So we will be learning about metadata, and we're excited to have Erin Wolfe with us today. So Dr. Graham, I'm going to turn it over to you.
Okay, thank you, and good morning, everyone. IDH, our introductory to the Digital Humanities, the introductory group. It's good to see everybody. Hopefully more people will join. I'm excited to be here today because this is something that I'm both afraid of and always want to learn more about. So thank you, Erin, for joining us. I want to say Erin has been with us from the very beginning. He was not in the KU libraries until I think 2017. He had been at the Dole Institute. Those of you know, we have the Robert J. Dole Institute here at KU. So Erin was there. Had we known he was there, we might have been bugging him earlier, but we started bugging him when he joined the library staff. I think in 2017, you came over and we were starting our creating metadata, specialized metadata, considering that took into account racial difference. And Erin was central to that process. So he's been a partner with our project since that time. Currently, he is the Digital Initiatives Librarian at KU. Earlier, he was a metadata librarian, which is, of course, why we went to him and still rely heavily upon his knowledge. He is not a native Kansan, I don't think. Is that the case?
Well, I was actually born in Emporia.
Quite important. Okay.
I moved away when I was about 1 year old, so it's
you went west, right?
Tenuous at best.
Okay, so but anyway, he's one of the, and I hope he'll talk more about this. He's actually been actively doing some of the presentations that involve some of the work that we are engaging. So some of you will get to see perhaps some of the ways in which you can make use of this knowledge, but metadata is so central to everything that we do. But he has a host of publications and memberships, and some of those presentations, have, as I said, have made us feel really strongly that what we're doing is important, and Erin has taken the opportunity to kind of take it a little bit further. So I'm going to let him give you any more particulars about what he's been doing lately as he introduces himself. But I just wanted to make sure I give him proper thanks for being on our team for so long, and for helping us to stay focused and stay current in areas that we don't have expertise. And so our partnership is one that I value. So Erin, I'll let you take it away. And I see no more people are joining. And so for those of you who just came in, I'm just at a few words of introduction to Erin Wolfe, who is a metadata librarian. Currently, his title is a Digital Initiatives Librarian at KU Libraries. And so I'm going to turn it over to him. Thank you, Erin.
All right. Thank you, Dr. Graham. I'm going to share my screen, which is that one. And I am going to just turn off my video because I find that I tend to get less distracted if I don't have to see myself on the screen. So, all right. So, yeah, so as Dr. Graham said, I'm the Digital Initiatives Librarian. Previously, I was the metadata librarian, and I was a digital archivist at the Dole Institute, which is a small congressional archives here at KU. I've done some advanced certifications in digital libraries and digital archives. And so I've been working with metadata and this type of stuff for quite a long time. I think 11 or 12 years in this capacity. And so that's just to say that I'm familiar with metadata and I know how it works and it makes sense to me and I enjoy working with it, but I know that's not the case for everyone. Dr. Graham even just said that she gets scared of metadata sometimes and wants to learn more of it. I've heard that just about every talk I've given, somebody says. So I would just like to say that doesn't have to be scary or hard. It's just a little bit complicated. And so what I'm going to do in this workshop is to kind of break it down so that it's hopefully simple to at least grasp the basics of it. It can certainly get very complicated, but it doesn't have to be, especially for the types of projects that most sort of individual researchers do. This webinar is going to be about metadata and dataset creation. And as you'll see, there's a lot of overlap between the two. And so as I go throughout, just try and think of, know that this is going to be applicable in different ways as you move through, and kind of think how this might apply to your project. I don't have the chat up, so if I kind of cut out or something and somebody can't hear me, or if there's a question, I should have some time at the end for some questions if anyone has any, but feel free to unmute and speak up if there's something that needs to be addressed sooner. So I do have kind of a lot in this presentation, so I'm going to go kind of fast through a lot of it, just so that we have time to get through it all. But this is sort of the general overview, talk about metadata basics. I'm going to briefly touch on Dublin Core because that's a very common metadata schema, metadata standard that's used by Omeka and Scalar and some of the other common DH publishing platforms. We'll talk a little bit about data set creation and just a tiny bit about sort of managing data. Let me get to one more thing here. There we go. Okay, so we're going to start at the beginning and just ask, what is metadata? Well, metadata, it has different contexts for different people and in different fields. So for me as a digital libraries person, it's going to mean different things than somebody who works in the telephone industry or maybe a biologist doing field research. It means different things to different people, but it's essentially the same concept, which is that metadata is data about data, which, you know, is a pretty great definition. I think we know all we need to know now. When I remember my daughter was about 8 years old, and I told her this, that she asked what metadata was, and I told her this definition. She just kind of backed away slowly, which I think is a common, you know, response with this sort of thing. But let's look at it a little bit more, and let's take a higher level and ask, what is data? If metadata is data about data, well, what is data? It's information in a raw, unanalyzed form, which represents the values of a certain observed population, condition, or subject, or a set of qualitative or quantitative variables about one or more persons or objects. Qualitative just means something that you can count, and qualitative is things you can observe but not necessarily count. So if we were talking about this webinar, qualitative might be how many people are attending this webinar, and quantitative might be what subjects are covered in this webinar. Data obviously can refer to lots of different things, and hopefully it'll start to make sense. You might think of it today just for your project. And what's your research product? What supporting materials do you have? If it's just a text file with numbers, if it's a folder of digital images, and the documentation that helps it make sense. So if you come back to the question of what is metadata, this is taken from the ISO standard on information and documentation for records management, which says it's data describing the context, content, and structure of records and their management through time. Now, we're not working with records management, probably, but those that bit in the middle there is key for what metadata is and what it's used for. It provides context, describes the content, and allows computer systems to provide structure to the data or the resource. So do we need metadata? Yes, you do need metadata. This is a little collection of data. I would challenge anyone to guess what this is without any sort of context. I know that this was actually taken from the institutional repository at KU libraries, and I know that this is the #Black@KU Twitter archive. And so with this context of metadata, we know sort of in the abstract, you can see that it was who sort of started this hashtag, what its function was. In the description field, you can see what this data set is. It's a file containing tweet identifiers. And the identifiers can be used to query the Twitter API and gain access to the full tweet data. Making no claims about current or future Twitter management. Traditionally, the Twitter terms of service say that you can't store anything of any content of a tweet in a data set and be published, because if a person wants to say delete a tweet or delete their account, they have the right to have their tweets also removed and not floating around. So you take this string of numbers and query the API, and then you get the information back. But at least, so that doesn't tell us what these individual numbers are, but we know what this set of numbers is now. And it's because of metadata. So metadata, just to dig a little bit deeper, it first came up in the 1960s in regard to digitized data. It was first sort of used as meta language, and it evolved fairly quickly into metadata. And it's basically a statement or a set of statements about an item, and we'll talk about that in a little bit. And just know that anything digital has metadata. Whether or not it's descriptive metadata, it has metadata. Whether or not it's useful to you, that's a different question. But you take a picture with your phone, it's got all sorts of metadata that the camera puts in there. Create a file on your computer, same thing. Anything digital has metadata. And non-digital things also have metadata. And this can be sometimes helpful to think about this. So if you've got a book in front of you, a physical book, this is your object. But there's a lot of things that are not the object itself that can give you context or information about it. So if you look at the title or the author, you can see sort of the number of pages it has, all of these things that aren't the book, but they tell you something about the book. And it's the same concept. So metadata is anything that tells you something about the digital object. Here are the types of things that you might get from metadata. Don't worry about remembering these because you don't really need to know them. I'm just going to sort of go quickly through them. There's descriptive, which tells you about the information resource. There's structural. So how does a computer know that page 54 comes before page 55, for instance? There's metadata that's used to manage information resources like usage and rights metadata, who can access this content and what can they do with it. Technical, this is mostly created by and used by computer systems. Shouldn't have to do much with these, but that's a lot of things that are sort of automatically created and help a computer know what to do with an item. And then preservation, again, these are usually things that are handled by a computer system of some sort. And the one that most people are going to need is just this descriptive, maybe some usage and rights, but really, this category here. So thinking about what to collect, the most important thing that you're going to collect for a data project is what you want to do with that data. Do you want to be able to search by a year? Do you want to have subjects? Do you want to group things by author, things like that? But then also the type of item that you're beginning with is going to dictate what you maybe want to collect about that. So if you're creating a collection of web pages, you're going to have different metadata points than if you're dealing with a collection of oral histories, for instance. And so thinking through those things, and that's kind of a lot of the process for getting set up to do good data collection, data set creation, and metadata creation is thinking through before you get started. And that's kind of be a recurring theme here. So it is important to recognize that there are plenty of wrong ways to do it, but there's not a single right way to do metadata, to create metadata. There's standards, there's best practices, there may be ways that you need to do things specifically for a particular industry or to work with a digital platform like Omeka, but there's not a right way. So even if I talk about some specific things, there's definitely flexibility, especially for individual projects. And we'll talk about that, maybe give some examples a little bit later. But you can think about metadata as an opportunity to bring structure and consistency to a project rather than a strict set of guidelines to adhere to. So digging in a little bit, looking at some definitions, we've got this picture here taken from the KU University Archives. Again, with no metadata, we don't know what this is. So let's look at some definitions. An element is a named field or category. So if you think about your metadata in a spreadsheet, this would be the column header, the title, date, photographer, location, anything like that. That the word title is the element. And then the value for that element, or the value is the data for that element. So the actual title of the image is the value. So in this one, it's LHS football, Manhattan players searching for contact lens at an LHS Manhattan game. So now we know more about this picture. And you combine those two things together, the element and value pair, that becomes the metadata statement. So earlier I said that metadata is a statement or set of statements. That's what a statement is. It's the element and the value taken together. So a title is good, but you probably want more than that. And so you make a metadata record, which is the entirety of those statements or element value pairs for an object. So we've got the title, the date, the creator, the call number, things like that. And just to get a little bit pedantic, it's not the entirety of the statements. It's the needed subset. What do you need for this object to make sense? So I ran this image just through a metadata extraction tool called EXIF tool, and there was 226 metadata statements embedded in it, and they all look something like this. We can see what camera took it and what software was used to process it and how big it is and things like that, but we don't need to know that for most of it. So it's identifying those things that you need for your project or that others might need to make sense of your data, of your subject, of your resource, whatever it is that you're creating this for. Just a quick note here, and I'll talk about this again in a little bit, but I just wanted to highlight it now. If you look at these keywords, we see that all of these have a word and then a colon and then another sort of word or couple words squashed together. There on the right side, file permissions, file type extension, those are the element. The part on the left of the colon is called a namespace. And those are that's just basically a way, to have some different, have different levels of control over the elements that are used and to let different systems talk to each other. And I'll talk more, hopefully that'll make more sense in just a little bit. Last definition is a metadata standard or schema. You've probably heard that before. And all that is a set group of elements that have been standardized for a particular use. So we'll talk about Dublin Core a bit. There's 15 core elements that make up the schema. So to stay within the Dublin Core schema, you just pick from those 15 elements. And that's what that means and refers to. And those terms are kind of interchangeable, standard and schema. And the reason that you would do that is that it ensures that all of your items, but other items as well, follow the same format, use the same labels. So using the word title to identify that sort of top level description. If everyone is using title, it's easy to identify what it is and for different data sets to talk to each other. Whereas if someone is using name and someone else is using article title, then it becomes trickier to sort of map them to each other. Do you have to follow a schema? You do not have to follow a schema. As we'll see later, it depends on what your intention for your data is, for your project. Again, I'll say that digital publishing platforms like Omeka and Scalar do follow Dublin Core. So even if you're not collecting your metadata in that schema, you'll have to map some of your elements to that schema in order to get it into Omeka to be able to use that. So again, depending on what your needs are and how you're going about it, it may be helpful to sort of start with something like that, or at least think about it. Okay, so again, there's not a right way to do this. You've got flexibility, but your data and your metadata should be structured and consistent. And I'm going to mention both of these things again because they're important. And consistency is probably the most important thing. So even if you're doing something wrong, if you're doing it wrong the same way all the time, it's easy to fix, much more so than if you're sort of doing it wrong a bunch of different ways. So again, planning, if you're getting started with your own project or wanting to sort of, think about a new data project or metadata project. So planning, decide on your list of elements, even if it's not a standardized schema. Use a spreadsheet. We'll talk a little bit about file formats later. One element per column. So not putting like the title and year in a single column. There's kind of common sense. Separating multiple values. Not using commas if possible. So if we had a book and we're thinking about genres for it, you could use commas to separate those. But then if you're thinking about names that have a comma in them or other data that's going to have a comma in an individual sort of piece of data, your last name, comma, first name, comma, last name, comma, first name, then it becomes trickier to parse those back out later. So a semicolon is good. The pipe button is good, which is that little button above the enter key that rarely gets used. But again, just be consistent with whatever you're doing. So I mentioned earlier that data should be structured. This is a cookbook. We've got the citation for the cookbook. We as human beings can read this citation and we know which is the author and what's the title, where it was published, who was the publisher, what year. Very hard for a computer to do that. Not impossible, but a lot harder. So what you do is you put it in a spreadsheet or similar. This is called structured data or tabular data. This obviously lends itself better for grouping things together, easily identifying which value goes with which element, and bringing things together. In that way, let's see. And again, just being consistent, thinking through some of the other variables that may come up. So subject terms, if you're using a place, try to be consistent throughout. Here's Lawrence, Kansas, written in a few different ways. Most of us would not default to writing it that last way, Kansas -- Lawrence, but that is the standard way that like the Library of Congress uses, or OCLC, which is a library subject authority, which will actually kind of touch on that just a little bit. Dates, the preferred method is this first one, which is a 4-digit year - 2-digit month - 2-digit day. And that's an ISO standard. It's unambiguous. It's clear what that is. And if you look at the last one in that list, which is 6/3/72, if you had someone from Europe opening your data and looking at it, they might read that as March 6th, 72 and throw off the data. the problem with dates, and I'm not going to look at this super closely, but just to be aware of, is that Excel doesn't really like to keep things in that ISO format. If you open up a spreadsheet that has dates in it, it's going to convert it to its own date format. It knows what it wants to do regardless of what you want to do. So just be aware that if you're working with dates, Excel may kind of mess with your data. And if it's important for it to be in a specific format, it may be hard to get it back to where you want it. Not impossible, but not as easy as you would like it to be. Names, doing things the same way each time, and then null values. Null values means there's just no data in that field. And so just thinking about, what if you have data that's missing? Do you want to use the word none? Do you want to use NA, or do you want to just leave it empty? But thinking through that ahead of time and documenting it is gonna help. So we're gonna look at a little example of this is a data set that was put together by some library staff for teaching data cleanup. And if we look here, you can see pretty easily what happens if you get messy data. Having those inconsistencies makes it hard to, for instance, find the average age, or to filter and get a quick count of which things match a specific condition. And there on the right, actually, you can see, let me get this in there. Here's an example where they've used NA. We've got an empty field, we've got the word none. And so we've just, this is called messy data. We don't want messy data. We want it to be nice and clean. And we'll look at how that looks later. But it's just a good example to sort of review and see what it looks like when things are done incorrectly and how to avoid that. And there are ways to avoid that through sort of thinking ahead and planning. This is what is known as a data dictionary. We've got our elements here on the left side. These are the things that are important for us to, oops, let me go back one here. There we go. These are the things that are important for us to track. We've got the type of field, free text, date, vocabulary, yes or no, a field description. So this can kind of tell you where you're getting the data from. And then some formatting. So like using the name, if the formatting is important, what does that look like and what do you want it to look like? This is especially helpful if you've got multiple people working on it, or maybe students, just so that everyone does things the same way. Or if it's a long-term project, you can kind of forget what you did before, and it's good to just have it documented. And it will help others to make sense of it as well if you get to a point where you're sharing it with others. I'm going to draw your attention to this one, which is the controlled vocabulary. In this example, we're identifying what type of press has published this book. Was it a self-published, was it a commercial or trade publisher, a vanity press or an academic press? And then we choose from those, and whoever is entering the data will choose from those as well. You know, it's more complicated than just a 5 term set usually, but these are the types of vocabularies that you might have. So thinking of things like subjects or place names or things like that, there's very good reasons to have an uncontrolled vocabulary, such as if you've got some user input, you don't maybe want to put restrictions on what terms they can use. But the problem there, you know, then you've got possibilities for overlap through minor variations or synonyms. So you may need to do cleanup after the fact. So with a controlled vocabulary, you sort of account for that by having a limited number of options to pick from. But that creates its own problems because a lot of controlled vocabularies aren't particularly nuanced, and you may not find the term that you want. So here's some types of controlled vocabularies these are commonly used by libraries and other cultural heritage institutions, so the Library of Congress, the Getty Institute. Those are really good. It's nice that they're used by many places because they can, it becomes easier for your data to talk with other data. But again, they can change slowly. They might have outdated or insensitive terminology. They may not have, again, the nuances that you want in your data. There's some community vocabularies that have arisen to sort of address some of those concerns. And so there may be a community vocabulary that gets a lot more detail with specific subjects. So like the women's studies or First Nations, LGBTQ dictionary and things like that. Those are just a few examples. And the other reason that you might want to use controlled vocabulary is whether or not it's from a organization or community, even if it's just your own. Here on the left, I know you probably can't read this because it's going to be very small, but each of these blue dots represents a person. And each of the lines in between, I believe that these are photographs. This represents a photograph collection. Each of the lines represents someone who is photographed together. So here in the middle, we've got Martin Luther King Jr. And each of the lines from him represents someone he was photographed with. And then you can see when there's lines sort of between the others, they are photographed with each other. And that is possible because they've used the same name and name form for each time that person is entered. So that's one of the, the benefits, just even for just working within your own data. Here on the right, this is it's a little bit older image now, but it's a bunch of little bubbles, and each of those bubbles represents an open data set. And I'm going to show what that means because it's something that it's kind of hard to make click. But again, it's hard to see, but there's lots of all the gray lines in between. That shows that one bubble is connected to another bubble. And so if you're using terms that a bubble knows about and it connects to another bubble, you can also sort of connect to that. And I'm going to show what that means with a little example. Up here at the top, we've got a link to wikidata.org /wiki/Q8027. If you're not familiar with Wikidata, it's part of the Wikipedia collection of websites, which there's quite a few of them, but it's the data arm, I guess. And I'm going to jump over there. So here is that page. So if we follow that link to the Q8027, which is called the Q number, just a unambiguous term, that takes us to the Wikidata page for Martin Luther King. Just like Wikipedia articles, some can be really, really, really long, and some may just have a few little bits of information if they're there at all. So you'll see a lot of stuff on MLK because, obvious reasons, but you're probably not going to find all of this data for all of your stuff. But so if you've identified this Q number, you can come here and look through this, the Wikidata, and here's statements. So we know what a statement is. It's an element value here. And so the element is here on the left in the gray box, and the value is on the right. So sex or gender is male. Birth name, Michael King Jr. Scroll down a bit, we've got date of birth, place of birth, date of death, place of death. I'm just going to scroll. I hope I don't make anybody seasick. We see his children, occupations that he's been identified in. writer, preacher, pastor, pacifist, humanitarian, and on, employers. So lots and lots of data that you can use. Probably you would want to use software to kind of parse out, but by linking into this data set, you can then access all of this data for your own project. And because it's linked to open data, that means all of this metadata is available for free and use. You don't have to get permission or anything to make use of this. I'm still scrolling because I want to get to this section here, which is identifiers. This also has element value pairs, and these make a lot less sense. VIF ID and then a number. What these are here on the left are other open data systems, open data sets. So by coming to this Wikidata page, I can follow this link on the VIF ID and get to the Virtual International Authority file for Martin Luther King. And so we've got some forms. You can see that this is more multilingual already than Wikidata. But if we scroll down to this section, we have works attributed to Martin Luther King. And so you can go through this and parse out this if this is useful to your project and get sort of a list of works that's associated with him. Another one of those sort of links out from Wikidata comes to archives at Yale. So this is an example of how a university has been able to link in their library collections to Wikidata on the public, just in the public sphere. So if you follow this gives you a collection of 7 collections that have Martin Luther King Jr. associated with them. Presumably through a subject heading, but they've used some linking software to integrate their data set with Wikidata. And just another example from Wikidata, you can link out to Goodreads and kind of dig through this data as well. And as far down as I scrolled, I'm not even halfway down the page here. So there's lots and lots and lots of stuff here. And all of these link out to other places that have other information. And some, again, are going to be really short and some are going to be long. So let me get back over to the slideshow. And I just wanted to show that because linked data is one of those things that's really interesting, but also not necessarily, doesn't necessarily make a lot of sense without sort of seeing it and digging into it a bit. The next couple things I just wanted to show, because if you do any reading, you're going to encounter these words. Taxonomies. And a taxonomy is just a controlled vocabulary that has hierarchical relationships in it. So we've got food, and then vegetable and fruit are types of food. We've got the fruit category, and subcategories would be berry or the apple pear category, and on down like that. And so when you encounter the word taxonomy, that's all it means. It's a controlled vocabulary that has a hierarchical relationship. An ontology is similar, except that it goes another layer, and it creates different relationships between terms. So this is an example. We've got that root up at the top, and then 2 categories of pizza and topping. The mushroom pizza is a type of pizza, but then with those dotted lines you follow, it says mushroom pizza has topping mushroom, and mushroom pizza has topping mozzarella. So that's obviously a silly example, but if you think about it from, again, in terms of books, maybe you've got the book title, and then you follow a little line to say, is authored by, and you get the author's name. And then with the author data set, you say, is author of, and so that's just what that word means. You're not going to have to create your own ontology. You probably won't have to use one, but if you do any reading on this, they're they're terms that took me a long time to figure out, to be honest, because they're used a lot more frequently than they're defined, I would say. Okay, quick touch on Dublin Core. I've got more stuff here than I'm going to talk about, but highlights are that it was introduced in 1995 to have a universal metadata schema that could be used for anything on the internet, was sort of the idea. So it's very broad, it's very flexible. It was specifically sort of its main function when it was introduced was digital texts, but the goal of it was to be applicable to anything online. It is the most commonly used metadata schema for digital humanities and cultural heritage institutions. The main set is that there's 15 core elements. Those can be qualified, and what that means is if you've got the date, for instance, you can have the date created or the date modified, and that can be expanded from 15 to a full set of 40, and that's known as extended Dublin Core or DC terms. We'll get just a little bit more taste of that in a minute. With Dublin Core, all elements are optional and all elements are repeatable. And that means that, there's 15 core elements, but you don't need to use all of them. They're all optional. You have to have at least one or you have no record of any sort, but you don't have to use all 15 of them. And you can have as many of a given one as you want. And they don't have to be in any particular order. So it tries to be as flexible as possible. These are the 15 that are the core ones. And I just want to point out creator here. And that's the reason, that's an example of their trying to be really broad. So it doesn't matter if it's a book or a piece of music or a photograph or a film or a data set. It's got a creator of some sort. And you don't have to worry if it's called the singer or the author or the artist. They're all the creator. And I'm going to show this slide here, which is a screenshot of the website. And the reason I'm doing that is because the Dublin Core Metadata Initiative, DCMI, is responsible for creating and also maintaining and making available the schema. But they also do a lot of other stuff, and their website is fairly dense. So if you just go to their website, it's not going to have this stuff right up front and center. You've got to click over on specifications and get down to looking at the terms. And then again, this here I've cut out some extraneous stuff just to highlight the properties in the elements namespace. These are those 15. So if you want to stick to plain Dublin Core, which I think Omeka does this by default, but it is extendable to use the terms namespace. But if you want to stick to just those simple ones, these are the ones you have to choose from. And then above it, these are the ones that are in that extended version in the terms namespace. And if you look here on this one, you can see that there's contributor and coverage and creator. So all of those 15 down here are also in this 40 up here. You just get all these extra ones. And then one more, I can find my mouse, there we go. One more look here is that this is when you click on any of those words, or if you get to one of their definitions, this is what you're going to see. You're going to see a URI, which is a direct link to this definition, a label, and a definition for that term. This one's real simple. A title is the name given to it, which is great. They do get a little bit more complicated or more explanatory, I'd say. I don't know that they're complicated. Like date with the comment. Recommended practice is to use the date, etc., according to that ISO standard, which is that 4-digit year - 2-digit month, that's 2-digit day. and then subject, again, similar thing. The comment says it's typically use keywords or key phrases or codes. Recommended best practice is to use a controlled vocabulary. Sorry, I've lost my mouse again. Yeah, so there's a lot of flexibility. They've got a recommendation, but they're not going to hold you to it. No, they're not going to force you to use a controlled vocabulary. You can put whatever you want in there, and it will still be a valid record. So I need to scroll over just a bit here. Okay. So coming back to Dublin Core, a note on the namespace. Now, earlier I mentioned this in the context of the digital image, where there was the namespace on the left with a colon and then the element name on the right. That's what this is here. And the reason you might do that is if you've got your data set that you're creating and you know that you've mapped some of these, you're going to put them in Omeka, let's say, and you know you've mapped some things to Omeka specifically, and let's say you've used the author in your metadata, but you decide to change that to dc.creator. And that just using that namespace can help you know that you've already sort of mapped that and decided where it's going to be. And if you have others that don't fit, it's either not mapped or maybe it's not important for the Dublin Core, what you're going to put into Dublin Core. But then also you could combine DC along with DC terms, so you can combine multiple data sets. And that's what I meant earlier, as it's a way for different sort of vocabularies, different schema to be able to be used in the same document through the namespace. I hope that makes sense. It's a little bit confusing, and then just ways to use those qualifiers. You can just tack them on the end. The authority, that means if you're using a controlled vocabulary, what is that vocabulary? If it's important for your collection, so if maybe you're using more than one and you want to track which terms are coming from which authority, you could add those on the end too. So that's sort of what that qualifiers means. I do get questions about multilingual metadata, and so I've got a couple examples here. I will say if you look online for approaches to multilingual metadata, you will probably find a lot of people who are trying, a lot of groups that are trying to figure something out, but very little in the way of sort of actionable results. But here's one way you could do it. Let me get back to there we go. So this person, it's from 2015, a collection of Chinese scrolls and paintings. Their field name, this is their elements. They've got, the first one, they've got title / and then some Chinese characters that presumably mean title. They've used DC map column, so they've got a separate column to say where they're mapping it to in Dublin Core. They've just got one for the title, so they're using that the same. But for artists, you see we've got artist, and that maps to creator. And then you've got some Chinese characters, which presumably mean artist. And that's also mapped to the Dublin Core creator element. Remember, those can be repeated as many times as you need. So that doesn't really cause a problem with the Dublin Core. What you will probably notice is that it's the English word creator for both. There's very few successful ways that the metadata element names are not English, if it's a sort of widely adopted schema. So I'm sure that if you were in China working with a Chinese schema, they would be in Chinese, but there's not a Chinese version of Dublin Core elements, if that makes sense. The other thing I want to point out about this approach here is this required column, which I didn't say earlier, but you might consider this for your data, especially if you've got multiple people working on it. Is this required? Yes, title is required. All the rest of them are optional. And that's probably due to the nature of the materials they're working with. But that's just something that you might think about. This is another way you could do it on a spreadsheet. It's keeping it all in one document. So your creator and date maybe are going to be the same, but your title, maybe you're going to have an English version and a Spanish version. Same with subjects, whatever. That's just another approach that you might take. Okay, so that brings me to the end of the metadata section. I'm trying to think how we're doing on time. I'm trying to squash a lot in here. So I think I've got time to go through, and we'll still have a little bit of time at the end for questions. All right, data set creation. So that was the other sort of aim of this webinar. So the good part about this part is that if you took the time to do all those things that we talked about earlier, you've thought through what data or what metadata you want to collect, what you want it to look like, what you're going to do with it. You've really done the hard work of doing that. So now you're ready to sort of populate the framework that you've made, and whether that's through software, sort of through computer scripting, whether it's by hand, whatever it is, you've done the hard work. I'm going to this slide here, just as a sort of put it on your radar. Fair data is a concept that was introduced just in 2016, but it's already been pretty widely adopted by a variety of disciplines. FAIR is an acronym that means your data should be findable, accessible, interoperable, and reusable. So findable means it should be discoverable, identifiable, and locatable, which means that people should be able to find it through maybe a URI and know what it is when they do. Accessible means it should be available. Even if your data is restricted, maybe it's sensitive, maybe you don't have rights to publish on it for any number of reasons. Maybe if the data is not accessible, the metadata about it can be open. Interoperable should be able to be understood by humans and computers. And reusable. So it should be sufficiently described and shared with the least restrictive licenses, again, in order to provide the widest reuse possible and the best possible interaction with other data sources. This is kind of a later step because you're not going to want to do this with your working data set, obviously. But when it's good to have that in mind from the beginning, so you can kind of start to format your data in that way if you're gonna make it public. Obviously, not all of these may be applicable to your project or your community that you're working with, but that's sort of maybe a guideline to shoot for. So if we look at what is a data set, a data set is a collection of data. You've already sort of decided what that data is going to look like. So to be more specific, it's a collection of cleaned and organized data and the documentation required to understand it. So think back to that hashtag #BlackatKU Twitter archive. It's cleaned and organized, but without that documentation, maybe it's a data set, but it's not useful in any context at all. So the key parts of this definition then is that we've got data. And again, that's going to come from, you're going to decide where that comes from, whether that's through using some scripting software to get data from text or from the internet or wherever, or if it's through manual sort of data collection. The data needs to be cleaned and processed. So again, some of this can be done with computers, but most certainly a human being has to be involved at some point. And you've taken that raw data and brought some consistency and order to it. And then the documentation. I said it a lot because it's important a lot. Good documentation is as important as good data. So I'm going to go back to that one with the dogs. Very simple example, just for descriptive purposes. These are the metadata elements that were defined by the librarians. The this is what was decided was important. We've got things like the breed, the age, the weight. And then you've got a data dictionary where those fields are defined by saying, you know, what is specifically is going here. You can guess by the element name, but just to be more specific and to identify how you want that number to appear. Again, this is a really simple example. And then you take those data points and you sort of rotate them into a spreadsheet. So now you've got a spreadsheet template. These are now your column headers, and you're ready to collect your data. And you bring in your data from its whatever the source is. This is raw data. This is messy. We already looked at that. And what you want is something you can do with. So you clean that data, you fix inconsistencies and typos, you note where there's missing data. You can see that this is a lot more, just visually comparing the two, you can see that one of them is going to be a lot easier to work with if you've worked with, you know, a spreadsheet at all ever. I'm not going to pull up the documentation, but I will point out that this 99 is not a data entry mistake. A 99 was their code to indicate that there was missing data where they thought something should be. So a dog should have a height, like that's a natural assumption. So this means there's something missing here that there should be here. Whereas the 0 over here means there's no data, but that's okay because not all dogs are going to have a medical condition. And we haven't talked much about documentation. I've mentioned it several times, but not talked a lot about it. So you really should document anything that you're going to need to remember later. So people put down projects and come back to them after a couple of years. Projects get shared. Projects like the Black Books Project get worked on by different people over a very large number of years, and computer files get really confusing. So the better it's documented, the more it's going to make sense. If there's important files, write that down in locations. What folder are they in? Or are they on the cloud somewhere? Codes like the 0 and the 99, if you've used abbreviations that aren't just like the standard ones, what are those codes? What do they mean? How was the data collected? Who all has worked on it? Where did it come from? What format is it in? Who can have access to it? What information would someone who's not familiar with that project need to know to understand it? I think the reasons for doing it are pretty obvious, but it's something that's really hard to do. Even for myself, I try to do it, but I'm inconsistent as well. But it's important. And especially if you have your eye toward making your data public, it's really essential. Should be as thorough as possible while still being clear and understandable and concise, and also sustainable. So if you've got a really good data set that you've written an article about, and you've kind of explained everything in your 15-page article, that's not really sustainable if there's maybe a change to your data, because that's going to be hard to update. And it's also not really concise to help somebody get a quick grasp of the project. Another little example might be if you're working, in your computer, is create a little text document called a README, usually saved as a readme.txt, TXT, or some variation thereof. And it should really contain all the essential details of a project or the data or the folder that you're in. You can think of them as sort of digital Post-it notes, and you can just sort of write anything you want in there to help remember what's in this folder or where it came from, or anything that's sort of important for that. And file formats, it's important to put your data in the proper format, because that's going to play a really big part in making it usable and making it useful and accessible. Basically, in a nutshell, an open format is one where the code needed to create that software is open knowledge. And so there's going to be lots of software that can open it. It can be used by lots of different software versus proprietary, where maybe only in order to access the file format, you have to have the software that created it. Microsoft is sort of somewhere in between because they own their standards, but they've also made them open enough that they can be sort of created and used by others because they want to keep their, their files out there. But if you think about like Photoshop files, for instance, pretty much you have to have access to Photoshop to be able to open those files. There's very good reasons why you would work with an Excel file compared to a CSV, and I'm going to talk a little bit more about those in just a minute. And so maybe consider working in Excel, but when you get to that point of sharing your data or making it public, use that open format, or maybe save both and just use that same file name with a different extension to differentiate between the two. And then one last thing on data management, and then I'm going to look at a couple examples, is making backups. Backups are super important. I've been giving talks and workshops on various aspects of digital preservation that have involved talks about backup since probably 2012. And earlier this year, because of a user error on my part, I lost about 3 or 4 months of work on a project that I had been working on. Because it wasn't backed up appropriately. I thought it was, but it wasn't. But the more work you put in, the more work you stand to lose. So make backups, preferably on 2 different locations. One on your computer, one in the cloud, one on a hard drive somewhere. All right, so that brings me to the end of the slides, and I wanted to go over. Looks like we've got just about 20 minutes left. So I'm going to look at a few things, a few examples, and then there should still be a little bit of time for questions if anyone has any. Okay. I just wanted to look at a couple sort of finished published data sets so you think about what it is that you need. Excuse me. Here's the Blackett KU Twitter archive in KU ScholarWorks, which is, again, the institutional repository at KU. And this has really, the screenshot that I had earlier was taken directly from here. All of this is in here. There's a little bit more information on here, but not much more. You can see that's all the metadata that's here, but it's enough to give you context and let you know what you need to know. And there is a question link here. And over here on the left, it says view or open database of tweet IDs. So here's where the actual data is. If I click on it, it opens it up directly in the browser. So I'd have to save it locally if I wanted to use it. But you can see here, this is just a text file with there's no column header. There's no other information here. So you really need to have this metadata to make sense of it. So that's just important to see. So if I just save this file, it's not going to save any of this metadata with it. So just thinking about that when you're publishing, but also when you're accessing data. And I don't know if you were all, hopefully you were able to see Kenton Ramsey's talk last week. He's got such a nice example of a data set. I've borrowed his as an example. So this is that Edward P. Jones short story locations that he talked about. It's stored in the Texas data repository. We've got some metadata right up here at the top. Talks about what the data is. Come down a little bit, we get a little bit more metadata. And then here we can access the data set directly. So if I click this one, it's going to download a zip file. So this is not just a single text file that's going to automatically pop up in the browser. So now I'm going to go to where I wanted to be before. All right. Hopefully you're seeing a screen with just like some water and trees at the moment. Okay, so let's look at, here's my sample data I've downloaded. The file from Kenton Ramsey, downloaded here as dataverse files.zip. So again, I don't know what this is. If I've gotten sort of data hunting and I've collected a few different things. So just be aware of how you're saving files to make sure that they're going to make sense when you come back to them. But if I click that to open it, here, obviously, this is going to make more sense. So we've got Edward P. Jones, we got locations.csv, I'm guessing that's some data, story overviews.csv, more data, characters.csv, more data, data dictionary.pdf, I know what that is, and a readme.txt, I know what that is. So let's just kind of dig at this just a little bit to see. So here's that readme. I'm going to make the text bigger. It was from an earlier one I'd opened, but right up at the top, we see, we have a date of when it was generated. I'll make that even bigger so people can maybe see it on their screens. It was created by Dr. Kenton Ramsey. We've got a nice header, general information. We've got the title of the data set, the author information with a contact email, principal investigators, date of collection, geographic location. So we've got a lot of information right there. But as we scroll down, we've got another nice header. Sorry about this. Another nice header that has sharing and access information, licenses, restrictions placed on the data, or limitations of reuse, none. So very clearly right there, he's saying who can use this for what reasons, anybody for anything they want. Data and file overview, another nice heading. So he's got a textual list of the what's in the files, relationship between the files. The data sets all correspond to one another based on column C, which is the story. So that's super good to know. So we've got three individual data sets, three individual spreadsheets, but we could bring them all together in any combination on that story column. Methodological information, how was it collected, who did it, my students and I, put it into spreadsheets in Excel, who were some of the people involved. So we've got the full thing, and even a little bit of information about the individual spreadsheets, 6 variables. So those are going to be our elements, our columns, and number of rows in each one. So you know what to expect before you even opened any of the data. So let's look at the data dictionary. Let me see what I can do about making that larger. There we go. So Edward P. Jones story overview. We've got the element. So this is that same data dictionary. I'm going to scroll down a bit. Characters, there's the second one. And so in role here, we can see it's not explicitly stated as a controlled vocabulary, but here he's identified the 1, 2, 3, 4 elements that can be in that field and what that means. So protagonist is the leading character or one of the major characters. And on like that character gender, again, selections to choose from. What are the characters? And you can tell by looking at this that these are not Dublin Core. These are probably not any schema at all. These are ones that he needed for his collection and for his research project. And if you saw his talk or if you've seen the website, you can see that it was very successful without any metadata schema. But he did put a lot of thought into what these element titles were going to be. And then another one of locations. And then just for fun, we'll open up one of these. Let's see, so I've opened up the CSV. I'm going to make it larger. I'm going to expand some of these so we can see there's a collection, the chapter, which corresponds with the story title, location type. This is another one of those controlled vocabularies. as you can see, we got business, 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 business. And so if you wanted to put a filter on these just in Excel, you could pull up all the neighborhoods and just see what they are there. Location name, setting, address, etc. And you can just scroll down and you can see, and this is just to kind of point out that even published data, just because it's published doesn't necessarily mean that it's fully ready to go. You may still have to do a little bit of cleanup depending on your use. So we see here, we've got some empty fields, which are just empty because there's not maybe a value to associate with K Street, right? They can't tell which zip code is being referred to. We scroll down a bit, some of these values are NA. Now, is that a function? As I'm going through, I'm seeing that, yeah, so I think it's just different people identifying. So, but a quick glance through the data, you can highlight those things and fix any inconsistencies that you come across. But I think it's a really great example of using, collecting multiple data points in different contexts by putting them into different spreadsheets, because I'm not super, like I haven't explored this data too closely, but obviously the characters are different than the locations, and but you know that just by looking at the names and bringing them all together, including them all in the data dictionary and the README. It's a nice little collection. And just one more thing I wanted to show. So CSV versus Excel. If I go back here and I open, this is that simple dog data set. You can see this is an Excel format, and it's got some formatting built in. It's got the column headers are green and in bold. You can put things here, put in a little function maybe to get an average. So if I want to know the average weight, 37.14, and because that's a formula, if I change this to like 300-pound dog, it changes the average weight dramatically, right? So that's Excel. Excel is great. You do lots of good things with it. But again, if I were to, it's not, you need to have something to be able to interpret it. So a preferred format is that CSV. So you can't see, but I'm clicking File, Save As, and I'm going to take that Excel and come down just a couple and select CSV. And CSV stands for comma separated values. And I'm just going to save that. Close that guy. So now, when I open that CSV, you probably notice some things right away. All that formatting is gone. Even the column spacing is gone. Any formatting is gone. And if I come down here to where I made the average, that's just the number. It's not the formula anymore. So if I change this to a 0, it doesn't change the average because the formula doesn't stay with the CSV file. And the reason for that is the same as the reason for the CSV being the best delivery method, which is that it's plain text. There's no formatting involved with a CSV file. We've got owner ID, comma, dog ID, comma, dog breed, comma, dog age and year, comma. And that's how Excel, or that's how any program that you open this in to make it look like a spreadsheet, it's going to separate on those commas. And the same with the values here, the 01 pit, comma, red nose pit bull, comma, 2 years. And it's smart enough to know that in this answer here, yes, he's neutered, there's a comma there in the middle of it, but they've put it in, the software has put it in quotes. So that it's just going to ignore that comma to keep things all together. And how does it handle missing values? You can see on this bottom line, column, 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 number, column, 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 column. And so that makes it a lot more usable to a computer if you're wanting to do some computational analysis on your data. Whereas if I open the Excel file in a text editor, it looks like that. And so you need something that can interpret that into tabular data. And if you're wanting, again, to do some sort of computational analysis, it's certainly not impossible, but definitely trickier with an Excel file than with a CSV file. And I'm going to come back over here, and I'm going to click on that one and say thank you. That's the end for me. That's my name. That's my email address. Please contact me if you have questions. It is literally my job to help students and staff and faculty and KU researchers with questions like this. I'm going to, there we go. So you will not be bothering me. It is not a waste of my time. It is literally part of my job, and I also enjoy it. So if you get started and you have questions, please contact me, and I will be happy to help. I've done several one-on-one sort of little workshops or working sessions, I guess I should say. But yes, so that's all I got. Does anyone have any questions? We've got a few minutes left.
Questions, anybody? While you're thinking of a question, I will say that it's interesting to see Erin do this sort of in hindsight, because we were doing many of the steps you saw him identify as we were starting with our control vocabulary, our metadata schema that accounted for difference in terms of race, etc. So we were going through several stages since 2017, 2018, and now 2022, to watch how you have explained it sort of in one fell swoop for people, and to think about our going along the pathway to do some of those things. My assignment now really is to go back and see how consistent we have been in following the steps that Erin led us through, and see where we have some fault lines, because there are some fault lines. So I need to go back and look at that. For instance, our Black Literary Suite is in KU ScholarWorks. Does it fit the model that you saw him lay out here? I suspect yes, but maybe not so much, because we haven't gone over it as carefully as we should have. But this is a really good way to think about how you structure what you're doing, one, but second, how you leave a paper trail. So I was pleased to see Erin talk about the documentation. We have teams now in the Black Book Interactive program or project, and each of the teams is doing a manual. This was something we added in this round of funding, because we were discovering that we were having to retread and retrace steps that we knew we had done, but there was no paper trail. So every team now that we are working with within the larger structure of BPIP, not the cohorts, but the structure itself, the digitizing team, the metadata team, the cleaning data team is required to produce a manual. So you can see that this really is a very carefully thought through process. So what it seems to me is that if you take a small version of what he's saying and you follow those steps, you will find it much easier to do the work that you're doing when you return to it, when you want to expand it, when you want to share it. So it's really good to think about how he has laid this out. Each time I see it, Erin, it's clearer to me. So I want to say that. We've recorded it, so come back to it time and time again, because it doesn't stick maybe on the first round. Some of you are working as professional librarians, so this is maybe more familiar than not, but it really is valuable for everybody, because we want your work to last. We want it to be sustained. We want you to be able to find it when you need it and read it when you need it and share it. So I can't stress enough how you might just, slow it down and see how this might work for you. It really benefits you in the long run. I just can't say that enough. But anyway, that's kind of my little spiel to say, and Erin is absolutely correct that you can reach out to him. I won't say 24/7, but we're almost like that with him.
You can email 24/7.
He really does get back to you. He really does answer your questions. He really does tell you, and Erin, you may remember, but that first workshop we did, just when you started working with us at the Hall Center, you said, what about your controlled vocabulary? You raised that question from the audience. And it really was like a bell went off because we were creating our own metadata schema. We didn't see whatever we saw out there, we didn't see it, it didn't work for us, but we had to say, okay, what do? We have to create our own. So we've had to follow this. So you may be in that position as well, having to do some things that you have to create because it doesn't exist. On the other hand, there's some things that can be adapted to what you're doing. And I think I can say now in hindsight, more stuff can be adapted if you give it more careful thought than having to create your own in every instance. So the combination of adapting and creating your own might be something to think about. But questions, comments, and I know people are thinking about this, but I want to make sure. Okay, Leah?
Yeah, I have a question. I just didn't want to step in front of any scholars if they have questions also.
I have a question, but I'll go after you, Malia.
Are you sure?
I'm positive.
Okay. Okay, so the entire time you were talking, I was thinking about how someone would figure out the metadata world like on their own. Like maybe if they're curious or they're an independent researcher or they're not in a program like this one, you explaining it made it a lot easier. I think it can still be overwhelming though, but worth it in the end for the sake of like the visual representation and the accessibility examples that you showed. So my question is, what advice would you give to people who are beginners, but are maybe feeling a little intimidated by all of this? Like, is there a bite-sized starter tip as opposed to like diving headfirst into all of it?
Yeah, I would say just kind of start small. I think just kind of thinking through your project is a good way to get started. I definitely have some resources that are, like you say, bite-sized and easy to get into, to understand a little bit further, and maybe in a different teaching format that maybe like hearing me talk for an hour and whatever isn't gonna convey. And unfortunately, I don't have those right in front of me, but I will send them to you, and you can sort of parse them out to the scholars, maybe put them online as some resources, because there's definitely lots of good stuff out there, but there's so much out there on metadata that if you go out, like you say, if you go out sort of looking on your own, it's intimidating for sure. But there are several good intro points, and I will pass those along to you this afternoon.
Yeah, thank you so much, Erin. This was really, really fantastic. A lot of information. I came in a little late, my apologies, so I may have missed this when you said it, but, and if this is a dumb question, I apologize in advance.
Nope.
I am looking to build a data set that probably doesn't exist yet on Zora Neale Hurston. And I'm wondering, does the metadata, I know what the metadata is, but does the data set ever sit in a kind of repository or whatever that you use to search as a search engine? So is the metadata, the data set, is it something that is, you use it for. So you can use it as like a search engine for something. So if I had this data set of information about Zora Neale Hurston's plays, and I had it like all cataloged in a particular order, and I stick it in Omeka, on the back end of Omeka, would people actually be able to go in on a search engine and be able to like search what it is that am I understanding like data set like that? Or this is like the uses that you talked about in the workshop or in the webinar, that's really what the data set is used for. It's more of like Dr. Graham was saying, like a paper trail.
Well, no, the data set, so the documentation is the paper trail. The data set itself, that's where, like, that's the important bit. And in order to access it, it kind of depends on what your data is. You cannot just put your data set sort of on the back end of Omeka and have that be searchable. Excuse me. If you sort of, yeah, I don't think Omeka would be the best platform for that. If you had a collection of images, say, and your data set was describing those images, and each sort of data point or data row was associated with an image, those could be brought in, and that would be searchable because they have Omeka sort of works on an object with bits of metadata attached to it, not a collection of metadata. Unless something's changed in the last few, it's been a few years since I've worked directly with it, but I don't think it would have changed that dramatically. So you would probably need, in order to make just a straight sort of textual database searchable, you'd probably need some sort of custom web design building, honestly, to the best of my knowledge. There's data repositories where, like with the Texas data repository, where Ken keeps his, and that's sort of accessible for anyone, but you can't sort of search it from that interface, I don't think. There is, I don't want to make promises, but I think that there is one that would sort of be keyword searchable, that your data could be highlighted as a search result, but not sort of to the level I think that you're thinking. So like if you put in a search term at the site level, the data set might come up as a search result. Do you know what I mean? But not sort of that point of data or the associated things that are sort of alongside of it in any sort of detailed way. And there may be better, and I'll look into that. Let me make sure I've got your name here. I will look into that and see if there's something that I don't know about, because I haven't looked for that specifically, but it's certainly not anything that I've seen. But I'll dig into that a bit and get back to you.
Thank you so much.
Yeah.
Are there other questions? Because I can think, I'm thinking about all of you who are here and the projects that you brought to BBIP. And I'm thinking that you want to end your period of work with us with what it is that you've learned today, using what you've learned today. You want to leave that. So one of the things I might suggest is that this is recorded, you review this, but also look at one of the webinars that's already on our website. There's a webinar where Kenton and Amy Earhart are together. Amy's is the second part of that webinar, and she calls it Big DH and Little DH. If you look at her Little DH discussion in conjunction with this, I think it might be very helpful, because each of you is likely doing a little DH project. And she makes a distinction between big data sets and what you think you might want to do and what you really can do. And we want you to be able to think about what you can do. Lavonda, Gina, I know I've been talking to different ones of you, Seth, about what you want to put into your data set, small DH. So think about spending some time listening to Erin's presentation again, but looking at Amy do her small DH project where she talked about this particular effort. She used her students in the class to work with. It's Texas-based, but it's a good example of a project that you start small and how you develop it. Then Erin tells us how to really make the steps work. So you end up with a data set, but you've created the metadata associated with it. So that would be a suggestion. Those webinars are in order, but you see the one that has Kenton and Amy. You do the section for Kenton. For Amy, because she is really good at that. I used it in a bilingual workshop and it worked. So I know if it worked in a bilingual workshop, it would work. Because I have translators translating what Amy was saying in Chinese. And yet people really, I could see eye bulbs flashing and people like, yeah. So, but what they were missing was Erin, your piece of it. So now I got to send them this recording to listen to that. Any other thoughts? Seth, you look like something is coming out of your brain here. Yeah. Okay.
I'll be able to articulate things later. It's quite a bit, so it's a lot to think about and chew on. But thank you very much, Erin. I don't want to speak for others, but I think this is definitely something we'll be watching a second time.
There's some, and I had to cut so much. Like there's so many examples and other stuff that I would like to say, but yeah.
Yeah, Erin, I would ask you to look at our BLS on ScholarWorks and see what it's lacking. Because we did not do that. We didn't do the metadata. We just sent the raw materials. And so if you could take a look at it and tell us how we need to fix it, that would be really good. We know people go to it, but it's not as useful as it might be. And there are 10 of them up there now. I think the 11th one is just the one we've just finished. Black Beyond Borders, the Afro-Latinx Black Literary Suite that we just finished doing in September, October. But we've got 10 of those BLSs up there and you can search them. But I really would like some critique of how effective it is as it's structured. So an open invitation that Erin has given you, and he's serious, he means it. We have, taken full advantage and have been learning as we go, and he's kind of helped us to walk carefully and double back sometimes when necessary. But we hope that you will leave this cohort with something as strong, as effective, and as sustainable as he has suggested here. But I know you got to think about your questions, maybe give it a little bit more thought and look at the presentation again. I plan to do the same. So.
Okay, thank you everyone so much for coming. Thank you. Bye everyone. Have a good day.
Well, thanks for coming.